Hi, and welcome to the fourth tutorial in the tutorial series Python Basics. Last time we got familiar with single value variables. Often in Python, we're going to be wanting to work with sequences of variables. And when you have a sequence of variables, you're going to need to use a container of sorts. There are three main types of containers that we'll use very often in Python. Those are lists, tuples, and dictionaries. I'm going to give you the main takeaways of each container type right up front. So a list is a zero-indexed container. It is mutable, meaning it can be changed. A tuple is also a zero-indexed container, but it is immutable. It cannot be changed. And before I forget to mention, the list is the container for the list are square brackets. The container for the tuple are parentheses. The final container is a dictionary. The container for that are curly braces. And instead of being zero indexed, the index is provided by the user. And dictionaries are also mutable like lists. I'm sure that was very confusing if you've never encountered any of those before, but we're going to go over each type in a bit of a detail. So first we'll start with a list. This is, I think, probably the most common type. And we'll start by just defining one. List1 equals square bracket. And we'll go A, comma, B, comma, C, comma, D, comma, E, comma. Sorry. And we can just stop there. That's fine. So there's our list1, and Python accepts that. So now if we ask Python to return what is list1, Python returns it. And if we ask Python what type is list1, Python says it's a list. So this type function, it works both on variables and on these containers. It's going to tell you this is in the class list. Okay? So we have our list. Now, if we want to check out a tuple, we can do a similar exercise here. We'll say tup1 equals parentheses 1, 2, 3, 4. Python accepts that. Let's ask Python to return. Okay, we're returning the value of the tuple, and now let's say, what is the type of tup1? It's class tuple. One other thing to notice that I didn't mention, all of these containers, they separate the values with a comma. And I guess that's just so obvious to me that I didn't say it, but it's worth mentioning that you have to separate your values with commas. So list1 is a list of all strings, a string A, string B, string C, string D, string E, all separated by commas. Tuple1 or tup1 is a list or a tuple of integer values 1, 2, 3, and 4. And so now the final thing that I mentioned about them that make them different. If we can look at the elements of them. Well, at first I said they were zero indexed. What that means is that Python has assigned an index starting from 0 and counting upward for each element in the list or in the tuple. So list1 has 1, 2, 3, 4, 5 elements, but we'll start from 0 and count up. So it would be 0, 1, 2, 3, 4. And so if I ask Python to return list1 element 0, it returns the value A. If I've asked Python to give me the tup1 index 0, it returns the value 1. You might ask, well, why did you use square brackets now with tup1 for the index? Well, when referring to an index, you always use square brackets. In Python, if you type text and you have parentheses after it, that is usually reserved for either functions or definitions or such things like that. So we're going to stay away from using parentheses to get it at the index of a particular list or tuple. But a similar function that you can use is maybe you know what index you want, but you don't know what the value is. In that case, you can say that you want tup1 dot index. So you know that the value is 1, but you don't know what the index for that value is. In this case, it will return to you, oh, the index for that is 1. Similarly for list1 dot index, and we'll say, well, I know the value is a, but what is the index for the value a? It returns the value 0. So now we can also try to look at what happens if you look for an index that's not there. If I say return the value for tup1 index 5, it says, oh, there is no index 5. That index is out of range. And so that's our first forced error in this Python tutorial series. Maybe we've made other errors along the way, but this is the first forced one. And it's one of the great things about the interactive session, is that here we threw an error, but we can continue typing along, and if oh, I meant index 4. Oh, that doesn't exist either. Oh, I meant index 3. Okay, there it is. Index 3 points to the value 4. So one of the great things about the interactive session is that you can make errors all you want, and you can still keep on plugging away and trying new things. So one of the things I said about lists versus tuples is that lists were mutable, changeable, and tuples were not. What I mean by that is that once you've made a tuple, you can't change the values within it. You can't add or remove values to it. You can always redefine it, of course, but for instance, if I look at list 1, it's A, B, C, D, E. So let's say I want to add to that. I can say list1 dot append, if I spell it right, and we'll say append the value F. Python accepted that, and now if I ask Python what does list1 look like, it's A, B, C, D, E, F. Now tup1 is 1, 2, 3, 4. If I say tup1 dot append, let's add 5 to it. It's not going to do that because the class tuple has no attribute for appending because it's a immutable type. I could just redefine tup1 as 1, 2, 3, 4, 5 if I want to, but that's different. That's just the fact in Python that you can redefine anything you want at any time. For the sake of this, I'm going to just redefine it back to what it was originally, 1, 2, 3, 4, and we will move on. Okay, so we've seen the tuple, we've seen the index, we've seen that you can add, you can also delete from a list, but not from a tuple. So if I wanted to delete from list1, I could say list1 dot remove, and I want to remove the value C. So Python accepts that command. If I ask it to print list1, it shows A, B, D, E, F. Now it's automatically re-indexed everything so that the element I removed, C, was index 2, 0, 1, 2, right? But now D is going to be index 2. And Python automatically took care of that for me. If I try to take tup1 and again try to remove something, let's remove 2 from it, it has no attribute remove because it's not a mutable type. Okay, so those are our list and tuples, 0 indexed containers. So now we have something called a dictionary. I was introduced to dictionaries much later in Python, but they're very useful and very interesting. So instead of being 0 indexed, where Python automatically assigns a numerical index starting from 0, 1, 2, 3, 4, and so on, you have to provide the index for these. And so that's a little bit more work, but you also can provide an index that makes sense to you. And so to start off, we'll just say dict1 is an empty dictionary, and you define an empty dictionary with open and closed curly brackets. And in fact, I have something in the description you can just cut and paste in here, and I'll do that now. I'll say dict1, and so here what I'm saying is I want to define my dictionary in the following way. I'm going to have an index name, and name will be associated with the value Bob. And so the index and the value are separated by a colon in this case, and then a new value or a new element in the list or in the dictionary has a comma to separate that, right? So now index age is associated with value 99, comma, index height in quotes is associated with value age 72, index string country is associated with the value string the United States. And you notice that all my indexes are in quotes, and that's because I have to actually give it a string for the index. I can't, if I were to just put the word name in there, Python would think that I was asking for some variable called name. And so that's another thing you can do. You can define a variable that's called name and then make that, uh, but that might be more confusing than you're looking for. You probably want to use a string for the index here. So Python should and it will accept that. And now if I want Python to show me something, I can, instead of saying, so for instance, if I wanted to print, remember before I said list1 0, that's showing me the first element on the list1. In this case, I can say dict1 and square brackets name in square bracket. So what is the name that I've stored in dict1? And the name is Bob, right? So it's returning the same information in some way, but now instead of it just having an index that climbs as an integer, it has a name associated with it. It has the name associated with it. So you can see that could be very useful. Another way to define dictionaries, in fact, is the following. If I say dict2 is an empty dictionary, now I can add an element to dictionaries, like they're immutable, like lists are, with the following. I could say dict2 square bracket, and I'll put in a name. I'll say actually, instead of using, I can use anything. I can use any variable type. I can use floats, integers, or strings at least. So I could say 3.1415, which is a float, and that's going to be my key for the value, and I'll say the value is pi as a string. So that's a silly way to do it, but I've kind of showed my hand here that in dictionaries, the actual terminology is that we have a key and a value. And instead of it being an index now, it's a key. So for dictionary one, for dict1, all the keys would be name, age, height, and country. And one way to have Python show you those is you can have Python, you can say, one of the attributes is to say dot keys with open close parentheses. So dict1 dot keys, open close parentheses, and it shows you the dictionary one keys, name, age, height, and country. It almost looks like a list inside of a tuple, but it's its own data type, I think. I can ask it type dict1 dot keys, and it's a class dictionary keys. So if you wanted to convert that to a list, which is something I often do, then you would say list dict1 dot keys, and now it's just a regular list. If I did a type on that, which I can do just for fun, type, oops, spell it right. The type of that is a list because I told it to be a list. So, and now you can use it as a list, and that's where we're going to get into that in the next tutorial, but I'm going to move on from there. Furthermore, for dict2, I have in the tutorial series now, you could type a string, pi, or I did a capital P, and give it the value 3.1415926. And, oh, dict doesn't exist, but dict2, sorry, does exist. So there's an unforced error. And if I say dict2 3, there's an integer. So I can give it an integer index if I want to. I can say dict3 is equal to almost pi. And it accepts any of those. So you can use floats, integers, or strings as your key types. And you can have any value or you could have even more, you can have other data types as the associated value. So another thing I at the very end of this description for this tutorial, I start making crazy data types where I say, let's say redefine tup1 as 1, 2, 3, and I define tup2 as 4, 5, 6, and I define tup3 as tup1 and tup2 and list1 and dict1. And all that is accepted by Python. So Python I can even now do something even crazier where I can say list1 dot append tup3. And I didn't think that this would actually work in Python, but it does. And it's the craziest thing. And so now, if I look at tup3, it shows the first element is tup1, the second element is tup2, the third element is list1, the fourth element is dict1. But you can see that there's an element inside list1 that has these ellipses, these dot, dot, dot. That's called ellipsis. And that dot, dot, dot is the self-reference to tup3 that was added to list1 after it was first added to tup3. It's very confusing. But because Python, the way that Python stores data and the way Python does referencing, it somehow makes sense. If I print list1, it does the same kind of thing. List1 has tup3 appended to it. Tup3 has list1 in it, and so now it's showing list1 dot 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 in parentheses. So hopefully I haven't scared you away from Python. And normally in programming you would be much more responsible than this. However, um, hopefully you know a lot more about Python containers and variable sequences. And in the next video, we're going to get to the whole point of programming, which is loops and logic and having the machine do all the hard work. So I will see you in the next tutorial.